Okay, welcome back. In this installment, we're going to be talking about categorical logic and, in particular, categorical logic translations. So we talked a little bit earlier in the semester about inductive versus deductive arguments. We're only going to be dealing with deductive arguments for the rest of the semester. And so there's two main types of logic. There's categorical logic, which we're going to be doing for the next couple of weeks, and then later, after the midterm, we're going to be talking about propositional logic, which is a more advanced and sophisticated form of logic. But this form of logic was created actually by Aristotle many, many moons ago. And so categorical logic deals with things called classes, right? A group of things, right? Students are a class, teachers are a class, books are a class, things like that. And so we're going to be dealing with these classes and these arguments that regard classes, and we're going to be trying to eventually, especially in the next learning module, try to assess whether or not an argument is valid. And we talked about that again a little bit in the first section that we did of the semester, but now we're going to really put things to a test. And now for an argument to be valid, right, all of the premises need to be true, and the conclusion must follow necessarily from the premises. That's what it means for a deductive argument to be completely valid. Now, there's this other type of validity, right, that I guess you could call purely logical validity or just structural validity. It's an argumental form that is always kind of valid, structurally valid or structurally sound, if you will. Even if the premises are true. But if an argument wants to be properly valid in the proper sense, then all the premises must be true, and the structure needs to be valid. But for this chapter, and really from here on out, we're going to really just worry about that structural validity, which is namely how to form arguments, right? So we're not going to necessarily think too much about the truth of the premises like we did earlier. But we're just going to think a little bit more about the structural validity, all right? And so in categorical logic, there's four types of statements, and these are called propositions, right? And as I said, a categorical proposition deals with classes, and it says that one class in whole or in part is either included or excluded from some other class, right? So again, a class can be any collection of objects that has some specified characteristic in common. So like teachers, students, soccer players, chairs, things like that, right? And so in order to translate statements that are written in natural language into categorical propositions, this means that we're going to need to determine quantity and quality, right? So in terms of quality, the categorical statements are either universal or particular, right? So propositions that are universal speak about an entire set, right? All of the teachers, all of the students, right? None of the students, things like that. So an example, all insects are six-legged beings, right? It's talking about all of the insects that exist in the world, right? Propositions that are particular speak about some members of a set, or at least just one, right? So some college students are philosophy majors, right? Some soccer players are in shape, right? Maybe not all of them are. Well, most of them probably are. Now, in terms of quality, we're going to be thinking of either affirmative or negative, right? So propositions that are affirmative say something about a set, and they're mostly inclusive, right? All supermodels are beautiful, right? It's affirming that supermodels are indeed beautiful. Propositions that are negative deny something about the set, right? It says they're exclusive to a certain extent. Some supermodels are not drug addicts, right? It's denying that some supermodels are drug addicts. So as I said earlier, there's four different types. There's a chart in the notes. You want to maybe take a peek at it. So the four different types are the universal affirmative, the universal negative, the particular affirmative, and the particular negative, right? And let's just illustrate these really quickly. So UA, universal affirmative, UN, universal negative, PA, particular affirmative, and PN, particular negative. So these are, the UA are some, or no, sorry, I apologize. All, right? So universal affirmative are all blank are blank. That's the general template that those statements are going to take. The universal negative, you're going to say no blank are blank. Right? The particular affirmative, we're going to say some blank are blank, and the particular negative, we're going to say some blank are not blank. Right? And in those blanks, we're going to put in different classes, and eventually we're going to simplify classes just by one letter, one capital letter, A, B, C, D, the whole alphabet, right? So when we translate phrases, we are translating them to fit these templates exactly. All blank are blank, no blank are blank, some blank are blank, some blank are not blank, right? All A or B, no A or B, some A or B, some A or not B, right? So we're going to use capital letters to abbreviate some class. So that's why in the chart in your notes you'll see capital A's and B's. Translating means that you need to have a dictionary. So this is kind of like a map for somebody reading your argument. It's like the map's legend. It tells whoever's looking at your argument what the abbreviations mean. So A may stand for apples, B may stand for berries, so on and so forth. Right, or animals and bats, or whatever, whatever we're talking about in the argument, you want to make sure that you keep somewhere in there a little dictionary saying, okay, A is going to stand for this, or whatever letter, Q stands for quails, or whatever. So translating is, it's not always simple to translate these statements when they're written in natural language, just to fit into these templates, to fit into categorical propositions. Think about all the things that you can say in your everyday life, and then try to imagine simplifying them to one of these four templates. It's pretty difficult, right? For these to capture some complexities, which is mostly the reason why later in the semester we're going to study propositional logic, which is better at capturing more of the complexities of modern language. So some translations seem unnatural, but if you look on pages 184 to 189, M and K give you some good tips. You definitely need to read these pages. I honestly can't say what they say any better. So read those pages. They'll help you immensely, give you some really good tips on how to translate. So translating is not going to be as difficult in this section as it will be in further sections where we deal with propositional logic, but it is still going to be important to know just these four templates and how to put things into these four templates. So in categorical logic, we're going to be dealing with arguments known as syllogisms, right? And a syllogism is a categorical syllogism, right? Is a specific argument having exactly two premises and one conclusion, such that all the propositions are interconnected, right? So I give you the example. All humans are mortal, all Greeks are humans, therefore all Greeks are mortal, right? Now that's a categorical syllogism. Now let me show you what a syllogism isn't. So let's say I say some teas are hot, and then I say some coffees are not cold, therefore no soda is uncarbonated. Well, you may say, well, those are interconnected statements, right? Because they're all talking about beverages or something like that, and relative heat or something like that. But they're not connected in a way that really makes any sense. We really can't get to the conclusion no soda is uncarbonated by the other two statements. Whereas in our categorical syllogism, right, we see some connection. There's classes that overlap, right? Mortals is used a couple times, humans, Greeks, and we see how mortals, humans, and Greeks are all interconnected, right? Namely that all humans are mortal and all Greeks are humans, therefore all Greeks are mortal, right? So categorical propositions are composed of a subject and a predicate, right? Each of these things is its own term. We'll call it a term. So the example, the statement, all humans are mortal, contain two terms, right? The first term being the subject, that's humans, and the second term being the predicate, meaning mortals, right? So every categorical syllogism is going to contain three terms. It's going to contain the major term, the minor term, and the middle term. Now the major term is the subject of the conclusion, and the minor term is the predicate of the conclusion. You may have guessed the middle term, the other one, right? The one in the middle. So the term that's not in the conclusion. I'm not going to test you on whether or not you're going to know which one's the major or the minor, but it's just going to help, I think, in explaining certain things. It's important to kind of know that. So also the premise containing the major term will be called the major premise. The premise containing the minor term will be called the minor premise. Again, this is just kind of jargon, but it may help you read through M&K a little bit, and it will help us kind of discuss things via email. Whether you have questions, I may ask you about the major term or the minor term. I won't test you on it, but it's good to know, right? So the most difficult part about this categorical logic is the way to test it, and we're going to really get to that more in the next section when we try to assess validity. But for right now, we just want to know how to graph these things. So in order to test validity, we're going to use Venn diagrams, and usually with three, because we're going to have three terms. So three overlapping circles, and we're going to graph statements, or we're going to diagram statements, if you will. So, like I said, our Venn diagram will contain three interlocking circles. Each one will represent one term in our syllogism. You can make one with only two, but since we're going to really be using three to determine validity, we're going to just use three. So, go ahead and give a nice drawing of a Venn diagram, right? This is the world in which the Venn diagram lives. Let me actually use a different color. It'll show up a bit better. Okay. Venn diagram box. We'll just call this one A, this one B, this one C. Those are kind of the generic letters I always use, just because they're very simple. It's easy as 1, 2, 3. Now, there are different zones here, right? Everything outside of Venn diagrams is zone 1. Everything here, zone 2, 3, 4, 5, 6, 7, and 8. Now, these numbers are semi-important because they tell you something, right? So everything in zone 1 refers to things that are neither A's nor B's nor C's, right? Everything in zone 2 refers to only things that are A's. Zone 3, things that are A's and B's. Zone 4, things that are only B's. Zone 5, things that are A's and are also C's. Zone 6, things that are A's, B's, and C's. Zone 7, things that are B's, things that are C's. And Zone 8, things that are only C's. This is, again, going to be important to know. Sometimes it may be helpful in kind of in our discussions to know the zones. But more importantly, to know what each zone represents. And you can kind of see it when you look at the circles, right? You can see that obviously this is where A and B intersect, so this must be something that A and B have in common. This is where A and C intersect. This is where A and C must have something in common. This zone doesn't intersect with anything, so that must be unique to A or something of that sort, right? So basically we're going to just go right into it and talk about how we graph each of our 4 statements, right? So let's start with a universal affirmative, right? So let's say the phrase all A are C. All A are C. Okay? Now, what a universal affirmative affirmative statement says, right, is that every A that exists is also a C, right? So what that also means is that there does not exist an A that is not a C. Okay, now it may seem like I'm playing with words a little bit, but it'll make sense in about a second here. Now, for the universal statements, we shade certain zones of the diagram, right? So for the universal affirmative, we're going to shade. And what shading does is essentially kind of eliminate things from the equation. Something that's shaded is no longer in play, if you will. So because all A's are C's, I want to leave only the A's that are C's left on the diagram, okay? And where do I have A's that are C's? Well, here are A's that are C's, and in the center, there are some A's that are also C's. Now, they happen to be B's as well, but nonetheless, there are A's that are also C's. So what I'm going to do is I'm going to shade zone 2 and zone 3. Now, why am I shading zone 2 and zone 3? I'm shading zone 2 and zone 3 because in zone 2 we have the A's that are only A's, and right, our statement is saying that those don't exist. And in zone 3 we have A's that are B's, and our statement, all A or C, is also saying that those don't exist. So by shading them, we're taking them out of the equation to a certain extent. All right. Now let's work on our, draw this whole thing. Let's work on our universal negative. Okay? So our universal negative is going to say something. So let's say no C or B is what we're going to work with. No C or B. So again, this is saying that there don't exist any C's that are also B's, right? This one's a little more straightforward than the universal affirmative, right? If there's no C's that are B's that exist, and remember this is universal, so we're going to do some shading. All we need to do is shade out the areas where we have C's that are also B's, right? Because remember, C is the subject, so we're worried about C's that are B's. There can be B's that are not C's, and that's fine, because we're more focused on the subject C, right? So where do we have C's that are B's? Well, in the center, so let's go ahead and shade that out. And also right here, right? B and C overlap, so let's shade that out. All right? A lot more self-explanatory, I think, a little bit more intuitive than the universal affirmative, but yeah. So let's go on to our particulars, right? Okay, A, B, C. So let's say some B are A. Okay? Some B are A. Now, with the particular statements, we're going to put an X in an area that is necessary, right? So the particular affirmative is saying that something exists, right? There is at least one blank that is a blank. So we're saying there's at least one B that is also an A, right? And that X signifies that one member, right? That one member of the class B that is also a member of class A. Okay, so we're going to put our X somewhere where we have A's that are also B's that are also A's, right? So where do we have B's that are also A's? Well, right here and right here. Now remember, we said at least one exists, right? Now I don't know if it exists in this zone or in this zone. Both are still open to play, right? Neither has been shaded, they're both open, so I don't know where it exists. So, but because I only know at least one exists, I'm going to put an X on the line between here and here, right? I'll make sure we see that. I'm going to put a line between zones 3 and zone 6, because that's where we have B's that are also A's, right? And again, this particular statement is saying at least one that we're confident of, right? And now you can't just put the X wholly in this area or wholly in this area because you're not sure exactly where it is, so you kind of hedge your bets, you put it on the line, right? Because both areas are still in play. Now, we'll see later when we graph multiple statements, and we'll see in the next video as well what happens if you shade an area and the area is shaded off, but we will deal with that next week. Okay, so for our last one, we have our particular negative. So we're going to say sum A are not B. Okay? Again, our circles. I love drawing because I draw perfect circles. Okay, so sum A are not B. We're saying that there exists at least one A that is not a B. Again, people find this one to be slightly counterintuitive. Right? But again, so we're going to put an X in a place where we have A's that are not B's. Okay? So where do we have A's that are not B's? Well, not here and not here, right? But in zones 2 and 5 we do, right? Because in zone 2 we have the A's that are just A's, right? So that's an A that's not a B, so check. And then in zone 5 we also have A's that are also C's, right, but not B's. And again, same with the particular affirmative, we're not sure if it's, we're sure that one exists, right? That's what this particular statement said. But we're not sure if it exists in this area or this area, so again, we hedge our bets, we put it on the line, okay? So when you're diagramming these things, it's going to be important to know, what we're looking for, what we're interested in, what the subject of our proposition is, and what we're going to do. So let's go ahead and just do a couple where we're going to diagram two propositions on the same graph, because this is eventually what we're going to do next week when we talk about validity, is we're going to diagram our propositions, or rather our premises, and see if the conclusion necessarily follows from that, right? So we have premise 1 is going to be some C are B, and premise 2 is going to be all B are A. Okay, now the most important rule when diagramming arguments, the most important rule is no matter what order the premises show up in, you always diagram the universal propositions first, right? And for good reason, because the universal propositions, remember, are the shading propositions, and the shading propositions take things out of play, right? And so when they take things out of play, it's important to kind of just get everything out of play first that's going to be out of play, and then see what does actually exist with our particular statements, right? So for this one, we're going to graph premise 2 first because it's a universal premise, right? Now, if you have two universal premises, graph either one first. It doesn't necessarily matter, right? So premise 2 says all B are A, right? So where do we have our B's, right? In this area. This is our B circle. So where do we have B's that are A's? Right? Where do we have B's that are A's? Well, here and here, right? So all BRA says that there only exist B's that are also A's, which also implies that B's that are not A's don't exist, meaning we need to shade out the B's that are not A's, which is this area, right? Zone 4 and zone 7, right? The B's that are also C's, but not A's. So we go ahead and shade that out. Okay. Now our other premise, some C's are B's, right? So where do we have C's that are B's? Well, we had some here in zone 7, right? We had some there, and so we had some there, But this zone is out of play, right? So before we may have put the x on the line, right, between 6 and 7. But because this is out of play, what we do is we put the x totally in this area. Now why is that? Right? Now remember, before when we put it on the line, we put it on the line because we weren't confident of where that one thing that we were talking about, right? Remember, some C or B says that at least one C is a B, right? And when there's two areas that represent C's that are also B's, we put it on the line because we're not sure where that one instance exists, right? But here, because this area, right, zone 7, as it were, has been shaded out and taken out of play by premise 2, we can with confidence say that our C that is also a B is in the middle in zone 6. All right? Hopefully that makes some sense. Yeah, we're going to continue doing this, and this is a lot of the things that we're going to be working on. So for the homework, you're going to be asked to do some of this. Actually, mostly just translating things like that. But next week, right? Next module, rather, next chapter, we're going to be talking about validity, and this is going to be very important. So practice. Use some of the problems from the book. There are some selected answers in the back. Try to work on those to practice and check your answers and things like that. Obviously, as always, if you have any questions, email me, let me know, and we'll take care of them. Alrighty? Sounds good. We will see you next week.